extend our assembler to be able to handle a couple more instructions. And there's also some reorganization that I want to do before we get into that. So let's go ahead and get started. We'll go ahead and create a branch for the video and hop into the code. So one thing I wanted to do was, I noticed that I created this times variable, but it doesn't ever exist outside the for loop. So let's go ahead and just put it in here. And I also noticed that the semicolons on the for loops that I had here didn't have a space, so I wanted to fix that. So let's go ahead and make a commit real quick. The other thing is, let's go ahead and move out this processing logic, which is basically going to be this piece here. Let's go ahead and pull that out into its own function. I think that it's getting kind of big, and we want to kind of separate it out. It's not doing anything Windows specific, so there's no reason for it to be in here. So let's just go ahead and move it out now. And we will make a new function for this. So this is going to be our main assembly code. So I was thinking of calling it assemble. Fix our indentations. And then there's a little bit of fix up that we have to do. So we no longer have the read file results, so we're going to want to fix that. And we'll take that as input. And except this time I'm just going to call the variable contents. Let's go back down here. And we'll take out the other piece, which was, if you remember, we were outputting, or we were setting the output memory directly, and we, for right now, are just going to pass in a pointer to that memory. So we'll take that out. Oops. Again, I'll just put it there for right now. And we'll call it output, and then also I'm going to change the memory index variable here to just be called index. Okay, so let's go ahead and say that we want a, let me do that, let's clean that up. All right, and I think that's it. So we should be able to say now should be able to just do that, and it should work. Except that I forgot to cast this guy to pointer there, and that's working. So let's go ahead and make a commit for that. So it's pretty straightforward. Okay. And then finally what I wanted to do is I wanted to move all of this parsing code into a separate file because it's not, again, it has no Windows specific logic in it. So if I go ahead and delete that, I can say that we want to put in assembler. So there it is. And then we will let's see, this is Windows platform. So we need to do that. Should work fine. Looks good. Looks good. And there we go. Okay, so something that we have going on is we can see that we have defined up here in our get token function the characters that constitute a hexadecimal value. And also we have that repeated down here when we are handling the token. What's this change? Okay, sorry. We can see that we have that down here when we're handling the token as well. So it's a little bit of duplication. It also makes this code here that's handling the tokens a little harder to understand. What I want to do is instead move the processing of calculating what the value is of the hexadecimal into the get token function. And in order to do that, what we're going to need to do is also have here on within token a value member so that we can populate it. So then what we want to do is say let's just put it here. So we come in, we have 0x, We got to set that aside. Then what we want to do is we want to say, so long as it's one of these things, we want to then calculate it. So we can't take use of the token length anymore because that's what this while loop was doing. I don't really want to have that big conditional statement as the continuation portion of the for loop. But if I don't, I would have to repeat the if logic inside so that I know which character to subtract the value from. Well, we could not do that, and we could have a true, just do an infinite loop and then break it when it's not. I think that's going to turn out to be the cleanest way to do it. The thing that I need to think about here is this result length. But I think that that's fine. I think we can handle it. So if we say here, we don't need either of those. So what we can say is, let's increment the length. This is going to be just let's continue to do it. Increment the length, multiply the result, not value, because that should be the token. And so let's go ahead and fix that for those. Else we want to subtract the result length. So what's going to happen is we're going to hit a non-hexadecimal character, but we've already incremented the result length. And we want to do that because we want I to be equal to that. And actually, I think this was wrong. Anyway. Okay, so this needs to say at and then I want this to say result dot length. And that's going to break us out of the while loop. That seems right. So then here, we can say if it's hexadecimal or if it's decimal. Actually, multi-reverse, then we can just say value token not value. Wow. All right, so basically then we need to do the same thing for decimal. Right? Yep. Except this should be result, not value. Same with that. Okay, so that just gets us out of having to define what makes a decimal and what makes a hexadecimal in multiple spots. So that all looks fine. You notice that we have the same bit here for decimal. So we could even do that for the times. Well, except that it's not a times, that comes back as a decimal. Okay, right. So then what we can do here is we can, when it's a times, we can get the token. And instead of setting it to 0 and then parsing the decimal value, we can here just say token dot value. Okay, that seems fine. Right, true is not defined, so we can either define it or we can just say while one. I'm fine with just saying while one. And then the issue here is that we're downcasting it. So that's fine. We'll just direct cast it for now. There we go. So let's actually run that, because that was kind of a more significant change. Let's see, do we... Yeah, let's load it in our binary editor or viewer. So that's what it is now. And if we run well, that doesn't look good at all. let's take a look. Oh, that's not the right file. Why did that fit? All right, well, we know it's going to be one of these infinite loops that was created, so let's just break in there. So what are we looking at? We need to know what add is, and we kind of care about result. Oh. What's going on? Well, it's right here. Or maybe not. That was really strange. Okay, so yeah, I think we want to do the add after, which will clean up the minus minus portions. Doesn't necessarily mean that we fix the problem. All right, so we're looking at E. That should be 9. Okay, that's wrong. Oh, that's bad. Yeah. All right, so I just had the where we need to do the multiplications and pieces wrong. All right. Okay, that still came back wrong. So let's look a little closer. So we're trying to read out 507. Still comes back. Right, the multiplication needs to happen first, but we don't want to do it on the time that we break. Gross. Okay, if we all right, what if we tried a different tactic? What if we went this way and said we want to do that at the end. It still does it because we have to go one more to detect it, right? That's what I thought. Well, I don't like that at all. We could put that in each of the methods. It just was nice to do it right at the top. We could do it and then divide. It has the potential to lose some information though, because we could wrap. Well, let's not let this ruin our night. We'll just do it this way. And man. All right. So that keeps now our code that's handling the tokens a little cleaner. And we're also not, the main point being that we don't have to specify what values represent a specific token. Okay. So the next thing that I wanted to do was to introduce a way that we can keep track of the syntax that we're building up. So there's there's formal ways to do this, and the one that I prefer is the extended Backus-Naur form, and I have no idea if I said that correct or not. But you can go to this wiki page, and there's some samples here that kind of show you what it is, and you can kind of see here you're building up definitions. So here's all the letters, some digits and symbols, and then this is the example that can show you how to defining the eBNF form in itself. Something that might be a little bit easier to understand is here's a stripped down Pascal definition with an example program here. So it's just defining the tokens for Pascal, which is a program keyword, and then the other things that can happen, and how you define a number and a string and all this stuff. So what I thought I'd do is go ahead and what we can do is we can add this eBNF here, and so to save us all from typing, I have a little bit already. So there's letters. We have then, this is going to be base 10 digits. What did I decide? I didn't like, I don't really like that either. I think I'll do hyphens. I don't know if this is technically allowed, but reading the definition, it was a little confusing, and some of the examples didn't seem to match with what's actually allowed. So we'll just do what we want. It just is defining the basic idea of what we're doing here. So what we have right now is we're saying that there's some things that we care about. We have an end of stream, we have a times, we have a defined bytes, we have a decimal and a decimal, and that's pretty much it. I don't remember, we are defining end of line even though we're not doing anything with it in the assemble function right now. But what we're going to want is we want to define all of those in the grammar here. So we had decimal is something, hexadecimal is something, end of line, which we know is /r/n. End of stream, which is the null character or 0. And so a decimal is, the way we would write this is that we would say it's a base 10 digit followed by optionally as many base 10 digits. That's not at all what I want. Similarly, the hexadecimal is going to be the same, except that it starts with a 0x. And then we also had define byte and times. I think that was all that I said, right? So we have end of line. Basically, these tokens up here are the things that we're going to want to make sure we have. All right, so times is the word times. So space. So that's where it's a little confusing because they don't actually say space anywhere in here, so I think it's implied. So let's leave it out for now. We can fix it later if need be. Anyways, for right now, we're only allowing decimals on the times, which isn't entirely true. It could be so in order to enforce that, what we would need to do is say here we only want to use the value if it's a decimal, and that would enforce it. Now that's arbitrary. We're just choosing to do that because that makes more sense. And then a defined byte so the idea here is that it can actually be we want to write the grammar in a way that makes it so that it's handling each line in our assembly file, and then we deal with it accordingly in our code. The issue here is that it's going to be a little out of sync. Let's go ahead and do it. So we can optionally have a times in front of a dB, and then we can have how does that get defined? I think it would be decimal or a hexadecimal. Right there. Okay. And then what we can do is we can say I guess like a file is one or more lines followed by the end string. So let's put these up here. So then what's a line? A line is I suppose we could say it would be proper to say it's a optional define byte followed by an end of line. So we could actually have blank lines in our file and it would process correctly. And I'm going to go ahead and change this, and I'm going to say numeric. So you can see that we have some identifiers in here that we aren't actually using. And that's just to build up the grammar in this file to make it easier. We might later on have the code match the grammar, but for right now we'll kind of leave it. And this is just to kind of help us keep track of where we are, really. It just is supposed to represent the code in a different way, and it's not really important if it gets out of sync or if it's not 100% correct, because the code's what matters to me. This is just an easy way to kind of look at it and think through if we're composing the instructions correctly. Okay, so I think that's what I wanted to do for that. Let me double check and think through. Yeah. Okay. There we go. All right, so now let's go ahead and add a new instruction. So to do that, I want to add a jump instruction. So I'm going to call jump, and it's going to just be JMP. And for right now, well, let's go ahead and say it has to be a numeric. And then what we want to do is we want to say we'll call it instruction is either a define byte or a jump. And then that makes it so that this just becomes instruction. Okay. So if we were to update our input file, and we added a jump, and I want to be, oh, we don't do minuses yet. Right, okay. Well, we can use hexadecimal. There we go. So if we do that, you notice that our file didn't change, and that's because the code right now ignores the jump instruction, provided I have compiling code, which looks like I do. So let's go ahead and add the jump instruction. So we're going to want to say jump and go ahead and do that. Jump, and it's 3 characters. And that's still not going to fix it. Oh, it looks like we had an infinite loop where we didn't know what jump was. So let's double check that. That actually looks true. It's not any of those, it's not any of those. So it's going to say it's decimal, and it's going to break, and we never moved the result, so we're still at the same spot. Okay. Well, let's fix that first. Let's double check. Yep. So let's fix X. We don't want to run into that down the road. So what I'm going to do is I'm going to say I'm going to define it as unknown by default. So then when we get the token, we can do this, and if we see maybe we can just break out when we run into it. It's not the best handling, but I don't really want to deal with I don't know what that was about. Let's see what's going on, because that should have caught it. Right, okay. Okay, what we want to do is we want to say back up here, if there we go. Okay. So it clears out our binary file, but it doesn't keep the program in an infinite loop. We'll we'll deal with handling that a little bit better once we get a little more structure to our how we're processing the text. So let's go back to adding our jump. If we do that, we get our binary file back correctly, but we still don't have that jump in place, and that's because we're not handling it in our assemble. All right. So if we see a jump, we want to get the next token, and that token should be either a hexadecimal or a decimal. And what we want to do there is we want to say token not value, and then the jump is an actual like instruction on the CPU, and so we're going to go ahead and we want that value to be EB. So that's going to say, tell the CPU to do a jump, and then the value is going to be where to jump to. So you notice now we have those two different instructions, and that's pushed off our boot record sequence off the end. So what we want to do is go back to our input, and we can get rid of these three lines. These three lines we're doing a jump. We're doing the infinite loop in a different way. This top line up here is doing an infinite loop by saying jump to -2, which is in hexadecimals FE, which basically just says go back to the beginning of the jump instruction. So if we do that and run, you'll notice now that our boot record sequence is just off by 1 byte. And that's because before we were using 3 bytes, but now we're only using 2. So we have to increase this times so that it will get flushed out, just like that. So so let's just double check that that's going to work correctly in QEMU. And we can see here that we're getting that happening properly as we want. I can never remember. Okay. Never remember the key command to close that. Okay, so that's cool. That's pretty good. Let's make a commit here. Excuse me. Now, the one thing is that writing the hexadecimal here is works, but it's not intuitive. What would be really nice is if we could use a label. So in assembly, a label would look something like this. We would say loop, and here we would say jump to loop. And I'm going to go ahead and tab it in. And so basically that's saying jump to wherever in the binary loop is defined, which is effectively what we had before, but it's just more human readable and understandable. This is probably going to not work. Because it has no idea what loop colon is or jump to loop or anything like that. So it probably had an unknown token there and just kind of failed silently. So what we want to do is we want to introduce the concept of a label. And a label can be a letter followed by optional letter or base 10 digit followed by a colon. And it's not really an instruction, but that's just the term that I'm using in here for right now. We can change this to make more sense once we've added more and figured out what words we want to use. The other thing that we need to do is we need to say now that well, that's interesting. How are we going to say so I think what we would need to do is say it can be a numeric or it can be a letter followed by optional letters and base 10 digits. It's pretty ugly. So let's change this and we'll say this is going to become something else. So we'll say a identifier and so then that becomes, I guess it helps if you can spell identifier. So a jump is JMP followed by either a numeric or an identifier, which is a letter followed by as many letter base 10 digits as you want. That sounds right. So we need to also add now labels and Okay, that's going to be a little tricky here in our parsing. So we'll say if it's greater than or equal to A, and less than equal to Z, then we want to handle arbitrary text values. So for right now, we're going to just go ahead and assume that it's a label. Oops. And what we'll do is we'll say while it's not equal to a colon, we will just increment the length so that we know how long the label is. Okay? And so then what we're going to do for right now is we're just going to mark where the label is. And for right now, we're only going to support one label. But we'll change this so that we can support multiple labels because we're going to need to. But for right now, let's just do the simplest thing. So we'll say label, and what we're going to do is we're going to just take a note of where we are in the output index. We also then need to know what the label text is. So maybe what we'll do is we'll have a label token, and we'll just capture that, and then we'll also say that the label value is equal to the index in the output. Okay? And then what we need to do is on the jump, when we get the other next token, if it's decimal or hexadecimal, we do that. Else, if it's if the token type is label, then what we want to do is say whatever the value is from that label. Now, that's not quite right. What we actually have to do is say what that label value is minus the current index. So in our specific case, the label value is going to be 0. Our index is then going to be 2, and that's what's going to get us the -2. So if we did that all correctly, which doesn't look like we did, let's figure out, oh, well, it doesn't compile. Labels not initialized, sure. Now it is. Okay, that still didn't come out correctly. So let's go ahead and walk through this. I'm going to care about when that happens and when that happens, because that's the new code. And maybe that too. All right, so we've detected that it's basically a alpha character, a letter. So we're going to keep going. And there we stop, so we have 4, which is correct. Right here, you can see that label is just not initialized. We set it to what the current token is. And we set the value to the current index, which is 0. Just happens to be what it was. That's fine. Oh, that was weird. Okay. Let's try that one more time. So we've gotten it. That's good. Get to next token. Oh, colon. Okay, so we need to deal with that colon. We don't want the colon to be part of the label. We want but we need to somehow pass it or bypass it. we could include it as part of the label. So maybe that's what we should do. Okay, that's bad. All right, well, this is turning out to be a little bit trickier than I had planned. So the problem here is that the loop and the jump instructions falling in here, and it's not doesn't have a colon, so it's going to read to the end of the string and do whatever with it. So what we really need to do is say, well, it's not a colon to keep parsing it. And then maybe what we can do is we'll say if, do that. We'll say if it does equal the colon, we'll consume it. And then what we'll do here is we'll say, well, it's not that, and while this one does not equal R, or actually what we can do is we can say and does not starts, string starts with at. Let's see, so while it's not a colon and it does not, our current where we're currently at does not start with the end of line characters. Well, that got us something. It's not quite right. I think that's a little bit closer to the right track. Let's do that. Here's the jump. It's going to be a token, or it's going to be a label. So there we go. So it's not that. So it's this. The value is 0. The index is oh, okay. That's right. This jump instruction needs to happen. Let's go ahead and put it there. So that's going to then move it over. It's only going to be 1 though. let's see, I want to write it into the one index and then increment it, but I need to subtract it as though it's already been moved. All right, so there we go. So we've replicated the value with the label now. So we can rerun it, works fine. We've also introduced an empty line, which I don't remember if our grammar allows for that. A line is an optional instruction at an end of line. So that's good. All right, so that adds labels. All right, so I think that's going to be it for today. Looks like there's a couple questions. What's the file list plugin at the bottom? Space HoneyPy, if you're referring to this bottom window here, that's actually just the current, what's it called? Current open window. So that's outputting the build files output into that window. I had it at the bottom of the screen because when we were looking at our grammar file, it was wrapping here, and I didn't really want to have that wrap. So then when I opened it up, I just left it there. And then he asks again, what command is actually written in that machine code text? Not entirely sure what you're referring to, but if we take a look at the input, and then we can take a look at this output here. So if you can see in the input, what we're seeing is we're saying jump to the loop label, and the jump instruction is the hexadecimal value EB, and then this FE, what it is it's basically -2, which says to move back 2 bytes, which would take you back to 0, 0. So it's basically an infinite loop. We're then saying here we want to write out a 0 byte 508 times. So that's all of this here. And then we're writing out the byte 55 in AA. And so then that's producing the 512 byte sector that the BIOS loads into when it's looking for a device to boot to. And so what this is doing is we can then run this QEMU, which is basically a CPU emulator, and that's going to load the first 512 bytes in that binary file, just happens to be 512 bytes. The 55AA is a boot record sequence that tells the CPU that you want it to boot from that device. And then the EBFE is basically just an infinite loop. So this is sitting here spinning now, and we can pull up Task Manager, and you can see it's running on this core, the CPU, and if I were to shut it down, that CPU usage would drop. So that's that infinite loop just running as fast as it possibly can. And what would normally happen if you didn't have a valid boot record sequence is that the emulator will run through various devices trying to find a something to boot to. So it's going to look on hard drives, CD-ROMs, floppies. It's going to then do some networking stuff to try and find it, and then basically gives up and says, I couldn't find anything to boot. So that's proof here that we're actually loading that binary, and that is correct. And this CPU emulator is running our binary code. Now, it's not very sophisticated binary code, but that's just because we're just starting out. But right now we do have the basic infrastructure to get going, and that's about it. So I don't see any more questions. What we'll do next time is we'll take a look at what we need to do to get rid of this 508. So if you noticed, if you remember, we had 3 instructions and we were going forward 507 times. And now with the new jump and label, that's only using 2 bytes. So we had to change the times amount to be 508. So we had to remember that, and we had to calculate it on our own. And so what we'll do is we'll take a look at what we need to do to be able to maybe write a little bit of code in here that the assembler will use to be able to figure out how many bytes we need to fill with zeros. That way, if we come up in here and we add a bunch of code in here, we won't have to like keep changing that number and keep thinking about it. It'll just happen automatically for us. So that's what we'll do next time. I hope to see you then. Until then, everyone have a good day.